So, just to continue off from where we left off last week and also today in lecture, I planned that pretty well, I think. Bravo for myself. Because we're going to talk about measured numbers again, right? And remember what I said in class and lecture, and like Miss Dickens is really going to harp on this a lot um, in class too, or in lab, right? Where say you have a ruler, right? In measured numbers here, you have a ruler, and something, this board here, right, measures to right about here. Whoops, I forgot to change it to drawing. This board here measures to right here, right? And so you're between 4 and 5 inches, okay? So that's the first thing you're going to write. You're at 4 inches, 4 inches, something, right? But then this number here, the number that's in this place, the tenths place, this digit right here, is going to be your guess, okay? And so it's pretty close to the halfway mark there, right? So you can say that's 4.5 inches, okay? So with those together, that means you have two significant figures, okay? Your first one is always going to be the number that you read off of the markings, okay? And the second one is always going to be the guess that's in between the markings, right? And the reason why that is too is because you can only guess between two markings. You can't guess any further than that because there are no other markings that go deeper than that, right? And so uh, this is how you figure out what the significant figures is for this particular ruler right here, right? If she asked you, or if I asked you, like if you have this ruler here that only has centimeters in there, right? That only has centimeters in there and no other markings in between in between 1 centimeter, and I ask you how many significant figures there are in this particular, or how precise this particular ruler is, you're going to say, well, I have 4 centimeters there, or just I have 1 centimeter there, right? And I can do the guess in between, right? Which means that's going to be two significant figures. Okay, remember that. So let's try that now here with this one, which I did last week already, but we'll do it again just because I know this is an important topic. I'm actually going to erase it so that we can let me do this here real quick. Just so we can see it clearly, right? So yeah, if you're looking at this ruler right here, oops, I always forget to do the pen thing. If you're looking at this ruler here, right, this ruler here is capable of reading to two significant figures. Why? Because you have the value at the line right there, right, and then you also have the guesstimated value in between the two lines. So that's two significant figures. So that's why that's going to be like approximately 4.5 centimeters, right? So the same piece of wood here is actually being measured down here now, right? The same. Someone's raising their hand, I think, or is that a chat? It's a chat. Bravo to myself. I just saw that. That was earlier. I just now saw it. When I clap for myself. Oh man. I'm not narcissistic, I promise. Not at all. In fact, I'm quite shy and quite uh, not confident and insecure about myself. So if you couldn't tell. So let's see here. What was I saying? Okay, there we go. Sorry, I had to get the screens back together since I went to the chat room. Anyway, so now the same ruler that's up here, right, is now down here, and you're measuring on this ruler here that actually has markings in between the 4 and the 5, right? So now you hit now your digit is not going to be the 4. You don't have to guess after the 4 anymore, right? You can actually get a little further than that. Okay, so this right here, of course, is then going to be 4.1. And this one right here will be 4.2, 4.3, right? And those are all measured numbers, all measured lines because they have the markings for it, right? And then 4.4, and then you have 4.5 right here, right? 4.5, okay? So that line right there in the middle, exactly in the middle, is 4.5, right? So are you done figuring out how many significant figures there are on this particular ruler? No. right? Because your significant figures will be the number that you can read, right, plus the guess. Okay, the number of numbers you can read plus the guess, right? So you can read the 4 centimeters part, you can read the 0.5 part, and the part that you're going to guess is that right there, right? Right between the 5th line and the 6th line, right? Right between there. And so your guess here is going to be 4.55 centimeters. Okay. So in the chat, tell me how many sig figs there are in this ruler, because you're going to be able to. You need to be able to do this with a graduated cylinder. You need to be able to do this with a beaker, with a pipette, with a burette, with rulers, all kinds of stuff like that. So in the chat right now, tell me how many sig figs do we have in this ruler? Or the other way of saying it is how precise. Precise? Precise is this ruler? Right? Or how many sig figs does this ruler go to? Right? Exactly. We have 3 significant figures here, right? We have the 4.5, which are the numbers that are given to you by the graduations or the markings, right? Marks, and then the guess, which is that last 5. So this equals 3 sig figs. Okay, everybody understand how to do that now? I promise you, you'll be asked this in lab. So when you get there, and she asked you about it, and you can answer it, you're welcome. Okay, you're welcome. So we already went through this before, but we'll just go through this real fast here. How many sig figs are here? That's 2 sig figs there, because all numbers are not 0 or sig figs, right? Here there are 5 sig figs, right? All zeros between numbers are significant here, so that's 3 there, 4 there, right? And again, I keep on forgetting that I typoed this and I didn't fix this, right? There should be a decimal point right there. And so, since there's a decimal point right there, right, that's 2 sig figs there. There's a decimal point there, so there's 4 sig figs there, right? Man, scientific notation's easy, right? So just the coefficient part, that's 2 sig figs. Just the coefficient part, that's 3 sig figs. Good stuff, okay? 0 is not significant if it is at the beginning of a decimal number, right? So right here, there's only one number there that's significant. That's a 4, because none of these are significant. That means that it's got 1 sig fig there. This one has 2 sig figs right here. Okay? And then all numbers that are used as placeholders, or zeros used as placeholders, not significant. So those aren't significant, those are significant. That means the 85 or the 850,000 only has 2 sig figs, and then the 1,250,000 has 3 sig figs. Okay? Just real quick. Oh shoot! Why didn't anyone tell me that I didn't put up the PowerPoint? Oh, I did put up the PowerPoint. Okay, good. I get so confused these days. Let's see here. Oh no, I didn't know. It's because I didn't do it that way. That's why. Because I didn't show my face at the bottom corner. It's probably better that way. My ego needs to be brought back under earth anyway. You don't need to see my face all the time. Okay, so let's go. When we talked about this a second ago too, exact numbers. Remember, exact numbers are usually numbers that we know that we can count, like 8 donuts, 2 baseballs, 5 capsules, right? And then those are also the metric and the imperial or U.S. system conversion factors, right? 1 foot equals 12 inches. 1 quart equals 4 cups. Oh my gosh! One time I was making some kind of stew. I don't remember what it was, but it called for like 1 quart of something. Maybe it was like cream or something. Or, no, it was water. It was one quart of water. And for some reason, I thought that there were 8 cups in a quart, right? And so I put in there. You can't see my facial expression, so I'm going to bring back my face. So I put in there 8 cups of water, and the thing overflowed the pot. And I said, "What the fuck?" Excuse me. I was like, "What the heck? These instructions, this recipe said 1 quart would fit in this pot, and it's not fitting. What's going on here?" Right? Turned out that there are actually only 4 cups in a quart, not 8 cups in a quart. Right? So, oh yeah. That's why I have Alexa around now, so I can ask Alexa what these things are, right? Or Siri. But Siri sometimes doesn't work for some reason. I don't know what's going on with her. She just doesn't work. She doesn't like to respond to me anymore. She's tired of me. Anyway, exact numbers are not measured. They do not have a defined number of significant figures, so you don't have to worry about that when you're doing the calculations. You know, when you're using these conversions, they're all exact numbers, so you don't have to worry about the significant figures. Remember, significant figures are only for measured numbers, and then they do not affect the number of significant figures in the calculation either, right? So let's practice some stuff in the calculator. This is great stuff right here, okay? This is fun stuff, okay? Where did I put my calculator at so you can see me calculating? Let me see here. That would be that one, maybe? No, that's not it. There we go. Okay, can everybody see the calculator clearly? Yes, thank you, Autumn. I appreciate you answering. I don't know about you guys, but I like ate lunch right before this class, and so now I'm getting sleepy too because I just ate lunch. And when you're at home, when you're working from home, and you eat lunch, and you're not having to give a class, you can, like, you know, take a nap afterwards. But giving a class right now. Okay, so this goes without saying, right? But this is one of those situations where you absolutely have to use what? The order of operations, right? Please excuse my dear Aunt Sally, right? So P for parentheses there, E for exponent, M for multiplication, D for division, A for addition, and S for subtraction. So a lot of people say that you can do multiplication or subtraction, multiplication or division in any order. No, you can't. You've got to use multiplication first and then division last. Okay? Same thing here. People think that going back and forth between addition and subtraction, you've got to go in order, right? Addition, then subtraction. So when you're looking at this particular number here, right? This particular problem here, how do you solve that, right? Some people might say, oh, well, you can go and do the 8.8, the 2.8 divided by 34 first, and then multiply it by 67. You could do that. You might get them right, but no, you shouldn't, because you might not get it right. You should always use the order of operations, and you'll always get it right. And the thing that students always forget, or they don't know already, is that whenever you have this division sign in the middle right here, right, what that actually means then is that everything up here is in parentheses, and everything down here is also in parentheses, right? And so now that both of those are in parentheses, what comes first? The division or doing the parentheses first? Answer in the chat. What comes first? Yes, doing the parentheses first. Thank you. Right? So you must always do the parentheses and a fraction first. Always. Okay? So make sure you do the 2.8 right here, right, times the 67.4 first. Okay? Make sure you do that first. Okay, so how do you do it in your calculator? Well, you turn on your calculator, number one, right? And I have a weird number in there. Whoa, 15 quintillion. I must have been talking about some DNA stuff. All right. Okay, so if you had a regular calculator, like a normal calculator, like one of these right here, which some people do have one of these calculators here. And let me just show you by making myself full screen, since for some reason my calculator camera is not working. For some reason my calculator camera is not working, so I'll just make myself full screen now. Hope you can see me full screen. This is like a normal calculator right here, right? And so if you have one of these, right, then the way you would enter the calculator in would be, right, 2.8 times 6.67.4, and then divided by 3.34.8, and then you hit equals, right? And that would give you that number there, okay? That would give you that big number there. And so the thing about it is that when you're using this kind of calculator, you've got to make sure that you put everything in order, right? And you can only see what you're putting in at a time, one thing at a time. So you type in the 2.8 like that, right? You put in the 2.8 like this, and then you go times, right? And then you type in the next number, which is 67.4, right? And then you hit equals, right? And then you get that number, right? You get that number right there, okay? And then And then you divide that by the 34.8, right? See, 34.8, like that, okay? And you hit equals, and it should give you the same number, right? So that number right there, which is glare in focus issues, there we go. That number right there, right, is 5.422222988, which is actually the same number as you see here, okay? It's the same number that you see there, all right? And so that's how you type it in one at a time if you had this type of calculator, okay? And so the thing to note here is that though this is the number that they're giving you in the calculator, that's not your actual answer. Your actual answer, right, has to be with the right number of significant figures, okay? So of these numbers right here, right, of all these three numbers, which one has the least amount of significant figures? Which one has the least amount? Yes, exactly. 2.8 does. And it has two significant figures. And so your answer here actually would be what? It would actually be 5.4, right? It would be 5.4, okay? And the reason why it's 5.4 is because you have a 2 after the 4 right here, and so you round down. You don't round up. If it's a 5 or above, you round up, right? And then it would be 4.5. But since it's 5.42, then you're going to round down to just 5.4, not up to 5.5. Okay, and so that's important there. If you're using this calculator here, which is the one that I recommend everybody getting, right? The one I recommend everybody getting is this one right here. And the reason why I like this one so much is because you can actually type it in as you see it on the screen in the calculator. Okay, so I'll make myself full screen again so I have to just be very cognizant about doing this. Okay, so you type in 4.8 and you go times, don't forget the parentheses, 6.7, 6.740, and then parentheses divided by 334.8. Right? So I can insert parentheses. I always put the parentheses even though sometimes there doesn't need to be, right? And if you can see here on my calculator screen, the reason why I like this one so much is because I really wish cameras didn't recognize faces so well, right? Is because you can see here, if I'm pressing the right button, yes, I am pressing the right button, it actually shows the entire thing I typed in on the screen. So you can actually type in and see what you're typing in, which is really helpful when you're doing these calculations in chemistry when there's a bunch of numbers to type in, right? And so you just press enter, right, and it'll give you the number. It should give you the same number again, 5.422, blah, 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 and it's going to be the same number of significant figures, okay? And so here's an instance in which you have numbers at the end of the zeros right here, right, where if you type in, if you put in 4.8, 8.00 divided by 2.00, you get the number 4 because the calculator won't give you the significant figures, right? So what do? You have to figure it out yourself. How many significant figures should there be, and what should the answer be? Tell me in the chat. Anybody? Oh, you can't see the PowerPoint. Thank you. There we go. Sorry. So you'll get this instance where you have 8.00, right, divided by 2.00 in the calculator, but the calculator will only give you 4 because it doesn't know how many significant figures there are. You have to figure out the number of significant figures. What's the correct number? It is, in fact, 4.00. Thank you very much, Courtney. And thank you for telling me that I forgot to move it back to the PowerPoint screen. Okay, I promise I'll get the calculator screen working, but hopefully we'll go back to class soon and I won't have to worry about it because this is such a pain, okay? All right, so the next thing is just conversion factors, right? Just so you know, yes, 3 sig figs, exactly. Just so you know, these are the conversion factors for the metric system, right? we can start out here, which is the right here. They don't even show it, right? But right here. Oops, sorry, wrong place. I drew it wrong place. Let me delete that line. There we go. Okay. So the so yeah, it doesn't even show it, but up here, right above here, right, is where the unit is with no prefix, right? So because under kilo, right, is hecto, and then under hecto is deca, okay? And so if kilo is 1,000, right, and then H right there for the symbol there, right? Hecta then is 100, right? And deca, which is D, or actually it's big D for deca, all right, is 10, okay? Which means then under that, which we continue up over here, is then we'll have the unit, the actual central unit, right, with no prefixes. With no prefixes, right? So this will just be 1 right here. Okay? And then you go below that, deci is 0.1, centi is 0.01, milli is 0.001, and so on, right? And so what that means then is that you can convert between the different prefixes of the metric system and the SI system just by moving the decimal point, right? So for example, if I had something like, um, say I had said 100 kilometers, right? How would I change that, convert that to 100 hectometers, right? Well, I'm only one spot away from hecto, from kilo, so all I have to do is move the decimal point over one spot. Oops, that's not where the decimal point is. That's where the decimal point is, and you went over one spot, right? And so now that means that 100 kilometers equals 1,000 hectometers, right? Which no one ever uses hectometers, but I just used as an example just now, just to show you the conversion, right? So say I have something like 1 meter. How do I convert that to say kilometers, right? Well, this is where the meters is right here, right? And so I'm 2 away, right? I'm 2 away from from kilometer, right? I'm 2 away from that. So all I have to do is move the decimal point 2 times. Sorry, 3 away from that, right? 1, 2, 3. So 1 meter is the same thing as 0.001 kilometers. So really, you're just moving the decimal point back and forth depending on where it is on the metric system. So let's do another one, right? So say I have 30 centimeters, and I want to go to millimeters, right? That's super easy because I'm only one away, right? One away from centi. It's hard to see when it's like on both sides, but when they're on the one chart, it's easy, right? 1 centimeter is equal to, all I have to do is move the decimal point over once, right? So the decimal point is right there. So I move it over once. That means there's gonna be an extra 0 right there, right? There'll be an extra 0 right there. And so that means 30 centimeters equals 300 millimeters, right? Easy as pie. And it actually just tells you too in the number right here how many centimeters move. See? So from here to here, from centimeter to millimeter, right? It goes from -2 to -3. That's a movement of one decimal point. So that's all the number of decimal points that you need to move, right? Or if you're going from decimeter to millimeter, it's -1 and -3, and so you move it 2 times because there's two spots, right? In there, there's a difference of 2 there, right? So moving with the metric system is super easy. The thing that's going to be a little bit more difficult will be the conversion factors for metric between metric and the imperial/US system, which I think Bella was on the ask before, but I will definitely give you this thing. I will not make you memorize this chart for an exam or anything like that, right? So I'll give you this chart here so that you'll be able to do the calculations between converting different units of length, volume, mass, and time from metric to imperial, right? Or American. So let's do some quick examples here, right? And I'm really sorry that I can't get the calculator to work here, but that, you know, I really wanted the calculator to work. I'm really sorry about that. Anyway, so let's do this first question here, okay? Let's do this first question here. Let me make sure there are no chats real quick too. Good, because that's a lot. Yeah, no, I'm not gonna make you memorize any of the conversions from. You might need to know how to do the conversions for the different metric system prefixes, but that's easy. You're just moving from, moving the decimal point in the tens position, like decimal point at a time. But I'm never gonna make you memorize the the metric to imperial system conversions. That's just, I would never make anyone memorize that. Okay. Okay, so let's try these out real quick. They're really easy, but this is the kind of thing. This is dimensional analysis, also known as unit conversions, right? So for the first one here, I have a person that weighs, whoops, I have a person that weighs 178 pounds, okay? And first thing to notice is that this right here, this number has how many significant figures? It's got 3 of them, right? So whatever you do at the end of this problem, right? Thank you, Bella. Whatever you do at the end of this problem, you've got to end up with 3 significant figures, okay? So what I always do is I write down what I start with, right? Which I start with 178 pounds, okay? And then I want to end up with what it's asking for, and it's asking for kilograms, right? Well, if I look back at this chart right here, right, I can see right there in the mass, right, here's the kilograms to pounds right here, right? There's kilograms to pounds right there. And so using that, I can say that for every 1 kilogram, I have 2.2 pounds, okay? And the thing that people always ask is, how do you know which one to put where, right? Your goal here is to do simple math and canceling things out, right? And when you have things at the top of a division line that are the exact same as things at the bottom of a division line, they cancel each other out, okay? And so the first thing you can do here is see that there's pounds up here at the top, and there's pounds right here, right? So all you have to do is say, okay, cancel out the pounds there, cancel out the pounds there, right? And so now all I'm left with is 178, and then the 1 kilogram, and then the 2.2. So notice that the thing that you want is the only thing that's left over, but once you cancel everything out, right? And when you're doing dimensional analysis, and someone called this fence post back when I was teaching this one a little while ago, they called this fence post, right? Because I guess they did it in high school or something. But what happens is that you always multiply everything at the top first with each other. You multiply everything at the bottom with each other, and then you divide the two numbers. Okay. So in this case, it would be 178 times 1, right, which is 178, and then divided by 2.2, right? And so that actually gives you 80.9 kg. And I'll tell you right now that the calculator will give you a number that's much larger, not larger, but like has a lot more decimals than this, right? But remember that your original measurement had only 3 significant figures. So your answer must also have 3 significant figures, okay? Let me just do this on the calculator quick and see what the number actually is, and then I can tell you. 178 times 1, right? And then divide that by 2.2, okay? But not 202, 2.2. That actually gives you this number here. The calculator actually gives you 8 0.909090, lots of 9 zeros, and then a 1, right? 9 1, something like that. So all that stuff there, you don't need any of that stuff at the end, right? Because it's only 3 significant figures. If you look at these 3 significant figures here, right, it's 80.9 because this is a 0 right here. It's below 5, which means it's not going to get rounded up. It's going to get rounded down to 9. So that's 0.9. Beautiful. Okay. Let's see here how. Let's talk about this rattlesnake now. This rattlesnake is 2.44 meters long. That's kind of long, right? Notice that it has 3 significant figures, so your answer should always end up with 3 significant figures. How many centimeters is the scale? Is the rattlesnake, right? So this is one of those ones where you can just move the decimal point, or you can do dimensional analysis. Okay. So say all you did was move the decimal point. Well, it's already given you that it's 2.44 meters, right? And you want to go to centimeters, right? If you look back at the chart over here, meters would be up here in the unit section, right? With no prefixes. And you're 2 spots away from centimeter, right? If you're 2 point, yeah, you can do that too. The reason why we do, well, you can do that too, but the reason why we like to do fence posts is because sometimes you're not doing just one multiplication, one division, right? Sometimes you're going like through a whole bunch of them, and you'll see in a second, okay? You'll have to do multiple at once, and then it's hard to keep track of which to do multiply first and which to do divide first, which goes at the top, which goes at the bottom, and so that's why we have to do it with using the dimensional analysis, okay? But anyway, back to this. Meter is 2 spots away from centimeter, right? From centi, right there. So if you go back to the problem, right? Since you're going from meter to centi, all you have to do is move the decimal point 2 times, right? So you can move the decimal point 2 times, like that. Okay. So now your answer is 244 centimeters. That's the coolness and the ease of using the metric system. Okay. But if you didn't want to do it that way, you can always use the dimensional analysis. You start out with 2.44 meters, right? And then again, you still want things to cancel by putting them on opposite sides if they're the same thing. So for 1 meter, you put the meter at the bottom so that it cancels out with that meter. You have 100 centimeters, right? And then all you have to do now is multiply the 2.44 times the 100, and then divide that by 1, and that gives you the exact same answer. 244 centimeters. Okay? So when you're going from metric to metric, it's super easy. All you have to do is move the decimal point, right? But when you're doing the other stuff that's between decimal point and between metric and imperial system, it's best to use the dimensional analysis. If you can do the math in your head, feel free, but if you do the dimensional analysis, you'll always keep everything straight because you'll know to cancel things out, and you'll always end up with the right units. Okay. Next one. How many minutes are there in 1.6 days? Right. How many minutes? I can tell you that there are a lot. Okay. Notice here, right, that we have, excuse me, 2 significant figures. Okay. So the answer must end up in 2 significant figures. So you'll write 1.6 days, because that's where you're starting out, and you're trying to go to minutes, okay? And you can just do this part in your head. You don't have to look at the chart, right? Because I do it the easy way. For every 1 day, because I want day to cancel, right? So I put day at the bottom. For every 1 day, there's 24 hours. Okay. And then for every 1 hour, I'll put hours at the bottom too because I want hours to cancel. Right? There's 60 minutes. Okay. So now I can cancel out day. I can cancel out hours. And look what I'm left with. I'm left with minutes, right? Which is what the question's asking for. Minutes, right? And so now all I have to do is multiply 1.6 times 24 times 60, and then divide all that by the bottom, which is 1, right? And that actually gives me around 2,304 minutes. Tell me in the chat right now if that's the correct answer. Is that the correct answer? No, it's actually not the correct answer, right? Why is it not the correct answer? Remember that we have how many sig figs in our original number, right? There's only 2 sig figs, exactly. So what should this number be, actually? Instead of 2,304 minutes, what should it be? Exactly, it should be 2,300. Oops, 2,300 minutes. Okay? Yes. Okay, because now you only have 2 sig figs there. Okay? Does that make sense? 2 sig figs there in the original calculation, and then 2 sig figs here in the answer. Okay? Good stuff, right? Everybody understand how to do sig figs now with calculations? Let's do one more, okay? Let's do one more. So this is one of those ones that's a little bit more difficult because it's a rate, okay? You have a person on a treadmill, which needs to be me because I need to lose some pounds, right? But this person is going 65 meters per minute. I feel like that's really fast for some reason. I really feel like that's super fast. 65 meters per minute. That's someone's going really fast on that treadmill. Okay. Anyway, because understand that when you say 65 meters per minute, that means every minute this person has run 65 meters. Okay, that's a lot of meters. Okay. Yes, they do have goals. So the question is then, how many minutes does it take for you or this person to walk a distance of 75? Walk? That's walking. That's like you got to be like sprinting. Anyway, a distance of 7.5 kilometers. Okay. Again, make sure you're noticing, right, that we have. Excuse me. Make sure you're noticing that we have a excuse me, two significant figures right here. Whoopsies, didn't mean to do that again. Two significant figures, and then two significant figures over here too. Right? If one of them had 3 significant figures, another one had 2 significant figures, right? Maybe you're right about that. What do I think? What am I saying? Okay, yeah. So if we had 2 significant figures here and 2 significant figures here, that's easy because the answer would be in 2 significant figures, right? But if one of them had 3 significant figures, how many would you go for? You would go for the one with 2 significant figures for your answer, right? What did Autumn say? It's like elementary math. Why does Bob need 225 apples? I have no idea. They're just throwing in numbers. So crazy. Anyway, so how do we convert that? How do we change it so that we can figure out how many? Because you have to do 2 things, right? Because you have to convert from meters to kilometers, and then you also have to have you have minutes already, which is nice because minutes is here. So you have to convert this rate. So what you would do is you would start out with the distance you're going, right? Which is 7.5 kilometers. All right. And then you've got to convert these kilometers to meters because that's the rate, what the rate is at, right? So every 1 kilometer, remember, so 1 km is down there because you want to cancel out the kms, right? And that's 1,000 meters. Okay. And you're pretty much done with that part right there. So now you need to introduce the minutes, okay? And it says here for every 1 minute, this person has gone 65 meters. That's super fast right there. I feel like it's fast. So what you're going to want to do here, since you're trying to get to minutes, right, you want the meters to cancel. So you would switch it so it actually says minute at the top, 1 minute, right, and then 65 meters at the bottom. Excuse me. Right? And you know that this is 1 minute. Whenever, if you didn't know this already before, right, if there's not a number in front of a variable like that or a unit like that, it's always assumed to be 1. Okay? So that's why it's 1 minute over 65. So you can cancel out the kilometers, cancel out the meters, and you're left with what you're looking for here, which is minutes, right? You multiply the 7.5 times 1,000 times 1, then divide all that by the bottom, which is 65. Okay? And so that should give you 115.38 with a whole bunch of other decimal minutes. Okay? That should give you that when you put that in the calculator, which makes sense. It'd take that long to get 7 kilometers. Okay? Is that the right answer? What's the right answer? Yes, Courtney, exactly. Right? Because we have 2 significant figures here, 2 significant figures there. So this number needs to be 2 significant figures, right? So you're going to look at these first 2 numbers here. You notice that this digit here is a 5, so you have to round up. You round the 1 up to 2 until you get 120 minutes. And that's your answer. Okay? Does that make sense to everybody? Okay? Any questions about how to do those type of problems? Don't worry, I will give you the conversion factors that you need to know for exams and quizzes and stuff like that. And well, quizzes will be in your notes, right? For assignments, they'll be in your notes. But for your exam, I'll definitely have the conversion factors there for you. I'm not going to make you memorize those. That would just be a terrible thing to do to a person, right? Making you memorize all that. So the last thing I want to talk about today, right, is converting between what is it again? I lost my train of thought. Oh, converting between the Celsius and Fahrenheit scales, right? And I told you in lecture that this is done using a graph, right? It's using a graph. So remember, for you to convert between Fahrenheit and Celsius, the equation, right, is F, or Fahrenheit, right, equals 9/5 Celsius plus 32. Okay, plus 32. And, you know, I've never really been a big fan of fractions in my life, which is another reason why I really like this calculator, because this calculator, you can see fractions in it real easily. So I would go through and go ahead and just do that math right there for the 9/5 and figure out what the decimal point is for that. And the decimal number for that is actually 1.8. Okay, I'm gonna write that again because that's a mess. The decimal number for that is 1.8 C then plus Celsius plus 32. Okay, and you can see now how it looks like a y equals mx plus b equation. Well, it's equation of a line, right? Because the Fahrenheit is the y-axis, the Celsius is the c, right? Celsius is the x-axis, m is the slope, right? So 1.8 is the slope. And then this right here, the 32, which is going to be the y-intercept. Okay, just putting together all the things we learned from last discussion. So you can actually put this on. I wish I would stop doing that. There we go. You can actually put that on a graph, like so, right? And we can say that that's our y-intercept, and that is 32 degrees Fahrenheit, right? And so we know that it's a line like this because it's an equation of a line. Okay. And then we know then that, oopsies, there we go. Then we know then that the slope of this line right here, right, is either 1.8, right, or 9/5, okay, which is always rise over run, right? So that would be 9 for the y, the rise, and 5 for the run. So that's your slope right there, okay? So looking at experimental values, of course, how did the people figure this out? But they did this by using they did experiments to see, right? But say this line here, up at the top here, right? Let's just make it a little bit longer. All the way down here, this is a Celsius scale down here, right? Degrees Celsius. That's 100 degrees, right? But if you take it over to the y-axis, where the scale over here is Fahrenheit degrees, right? Degrees Fahrenheit. Then that point there, where the 100 degrees mark meets the line, is 212 degrees, right? 212 degrees, okay? Cool, cool. And then if you go backwards a little bit here, and then you extend this graph even further out, right? Which you can do. If you didn't know that, you can do that. Okay. And over here, where it's at 0 degrees, lost my train of thought. Oh, sorry. Let me say that again. Over here at 32 degrees, the value for C, right, is 0 degrees, right? The value for C is 0 degrees. I don't know why I drew this extra extension out here. I didn't need to do that. Sorry. It's 0 degrees. And so that's why you're able to actually use this line to solve for any kind of conversion between Celsius and Fahrenheit, right? And so for those of you who have calculators that are not this calculator right here, where you can see fractions, but you have the other calculator, which is this one here, that you can't see fractions, I would convert it over to 1.8 so you don't have to worry about typing in a fraction, right? And now, whenever you have any Fahrenheit or you have any Celsius, you can just plug in the numbers into the equation 1.8 C plus 32. So say you had a Celsius, like you had 37 degrees Celsius, right? Which is actually body temperature, right here, where it is, 37 degrees is body temperature, right? Yeah, for humans in Celsius. You just plug it in right there, right? And all you have to do, remember your order of operations, you type in 1.8 times 37, right? And then plus 32. And that actually gives you 98.6, right? Degrees Fahrenheit. And notice it matches up perfectly with that over there, right? And you can do it the other way too, right? If you were to put 98.6, which is body temperature, equals 1.8 C Celsius plus 32. If you solve for C here, right, you can see that it's going to be the same number again, right? How do you solve for C here? Well, when you're solving for equations, you actually kind of go backwards from the order of operations, right? You're trying to make things disappear. So the first thing you got to do is subtract 32 from both sides. I don't know why I drew that line there. I don't need that line there, sorry. You subtract 32 for both sides. Okay? After you subtract 32 from both sides, so 98.6 minus 32, that gives you 666.6, right? And then over here, since you subtracted 32 on this side, that cancels out, right? Because 32 minus 32 is 0. So now you're left with 1.8 C, or 1.8 Celsius, equals 66.6. Now what do you do? Who knows? How do you get C by itself? How do you get the Celsius by itself? Anybody? If you have 66.6, right, and that equals 1.8 Celsius, 1.8 times Celsius, how do we solve for C? How do we get C by itself? What do we do? Yes, you divide both sides by 1.8. Exactly. Divide both sides by 1.8. Uh-oh. Uh-oh. Can I just put a decimal there, please? It's not letting me put a decimal there. Just trust me, there's a 1.8 there, right? And so when you divide both sides by 1.8, that cancels out that on that side there, right? And then you do 66.6 divided by 1.8, and you're left with 37 equals C, right? So notice how it's the same thing as over there. Okay? So that's the easiest way to do this, right? Just remember that this is the equation right here for converting Fahrenheit to Celsius. If you have Fahrenheit, you plug it into the F and then you solve for the C, right? But if you have Celsius and you want to go to Fahrenheit, you plug in the C and then you solve for the F. It's as easy as that, okay? Fahrenheit equals 9/5 C plus 32. Any questions about that? Because there will be questions where you have to go through and convert between Fahrenheit, Celsius, and Kelvin, which we talked about Kelvin already. Kelvin's super easy, right? You just add 273. That's all you do for Kelvin to the Celsius, right? So if you have something where you have to convert between Fahrenheit to Kelvin, what do you need to do first? You can answer in the chat. What do you do first if you need to convert from Fahrenheit to Kelvin? Well, you're all saying what I think you're saying, which is you got to convert from Kelvin, you've got to convert from Fahrenheit to Celsius first, and then go to Kelvin, right? Because you won't be able to do Fahrenheit straight to Kelvin. You have to go from Fahrenheit to Celsius first, and then go to Kelvin. Okay, remember that. Don't make that mistake. Okay. Any questions, anybody? And then yes, exactly. Use the please excuse my dear Aunt Sally. Any questions, anybody? You do have an assignment that's due at the end of the day today. A quiz will be posted as well. Do you have any questions? Just DM me on the Teams, right? And I'll answer your question. But that ends our discussion for today. And I was really hoping to end it a lot earlier than that, but I was having all these calculator issues, right? It's already up, right? Yes, it is. The quiz is already up. But yeah, I was hoping this would end a lot earlier than 2:30, but I was having all kinds of calculator issues, so I apologize for that. But yes, Bella, go ahead.
Regarding the quiz, is it based on lecture 2's notes?
It's based on lecture 2s, 3s, and 4s today as well.
Today, oh, okay. So the quiz.
Yes, that's the quiz. Yes.
All right.
In-person's class starts on Monday, right? So are we still virtual on Wednesday? We are still virtual on Wednesday. Yes, we will be in class on Monday. Yes, no problem, no problem. Don't worry, you still have a week to get over whatever you're sick with, Courtney. I mean, I don't mean to laugh at you about that. I'm not laughing that you're sick. I'm just saying we're lucky that we still have a week off before we go back to school. So.
The assignment and the quiz both are the same thing, right? Or there is a different quiz even?
Say that again, Kunjan.
The assignment and the quiz both are the same thing, or there is a different another quiz in right now?
No, they're different. The quiz is due at the beginning of class on Thursday, right? But the assignment is due tonight at the end of the day. And the assignment was only over. Thanks, Courtney. You have a good day too. The assignment was only over lectures 1, 2, and 3. Okay, but the quiz is over lectures 2, 3, and 4. Okay, those notes. Does that make sense?
Yeah.
So.
And the quiz is 15 minutes, right? The 15-minute time limit quiz is there.
Yes, but it's still open book.
Oh, yeah. Okay. Sounds good.
Okay. Bella, do you have another question? Your hand's still up.
Yep. I will do. See you on Wednesday.
Okay.
Well, I wanted to ask also regarding the Kelvin Celsius thing. I wanted to know, when you ask questions in like our exams, are you gonna like mention that what you want the answer to be in?
Like, oh yeah, that's what I have to do, right? I mean, how would you know otherwise?
Right. Just
If
making
I
sure.
Well, if I ask you, if I say, the baby's temperature is 99.9 degrees Fahrenheit, right? I have to say, what is this in Celsius? Does that make sense?
Yeah, it makes sense. And also another question I also wanted to know regarding the significant figures.
Yeah.
Are all our chemistry answers have to be in significant figures, or are they going to like mention if it should be in like significant figures or not? Because sometimes, I don't know, back in high school we wrote our answers based on our teacher would just tell us she just wants it in 2 decimal places. So I just wanted to know.
Yeah. So yes, here in this class, you will always have to do significant figures.
All
Okay.
right.
And so, because that's important, that's the reason why it's called significant figures.
Mhm.
So the significant figures, of course, is always based on the number that's measured that
Mhm.
has the lowest number of significant figures. That's
Mhm.
what you base your number of decimals on, right? It's not just 2 decimal places. You've
Mhm.
got to use the number of significant figures, just like we did today in discussion, right?
All right.
Just
Yeah.
like we did in these examples over here, right? These right here.
Yes.
Let me show you. Remember these examples over here?
Yeah.
The right. For example, I did this calculation here with the minutes to days. I came up with 2304 minutes, right? 2,304 minutes. But that's not the answer, right?
Mhm.
The answer is 2,300 because you
Mhm.
got to do two significant figures, right?
Yes.
Does that make sense?
Yeah, it makes sense. I did this activity during the weekend, so I was just kind of like correcting myself based on the significant figures thing.
That's
So,
actually going to be the thing that gets people the most, trying to
mhm.
figure out the significant figures or just even remembering to do that, right?
Yeah.
Remembering to do it because a lot of times you're like in a rush or in a hurry, 'cause especially on an exam, and then you type the number into a calculator and you get the number and you put in that number, right? And you forget to actually do significant figures. The problem with that though is that sometimes they'll be like they'll be on Blackboard questions where it asks you for a number and that number has to be exactly correct with the right number of significant figures or you'll get it completely wrong. Does that make
Yeah.
sense?
Yeah, it makes sense.
Yeah, because if it were a different thing where everything was like, I will have questions that are like handwritten questions where you work out a problem, on a piece of paper and stuff, and you can
Mhm.
show your work and you can leave out, and if you forget to do the significant figures, that's like -1 point or something
Mhm.
for a 10 point question, right? 1 or 2 points for getting significant figures. But on a Blackboard assignment though, it's exact, right? So you have to have the right significant figures or you get the question wrong.
Yeah. Thank you
Okay?
so much.
Yeah, no problem.